Hi, and welcome to Pre-Algebra. First we're just going to go over a bit about integers. You should already be familiar with this, either from our Math Foundations class or perhaps from previous coursework, but just so that we're all on some similar footing and have some common vocabulary, here we are. So our content objectives for this lesson is that you could define what is an integer, what are positive numbers, what are negative numbers. You could put them on a number line. You could add and subtract them and use that in application problems, and that you could also multiply and divide integers. And as far as language objectives, my bad, that you would be able to read aloud the comparisons with inequalities, that you could listen to a partner explain their answer, you could write whether a situation represents a positive or negative number, and that you could explain your answers, like why you said what you said, to either a partner or the teacher. So first off, I've used the word integer many times. Integers are the natural numbers. That's our counting numbers, 1, 2, 3, 4, 5, 6, continue on forever. They're opposites and zeros. So integers could be positive numbers, they could be negative numbers, or zero. So 0 is not considered positive or negative, but it is an integer. So some examples: -4, -3, -2, -1, 0, 1, 2, 3, 4. Obviously, there are numbers in between those whole numbers, things like 1/2 or 0.75. And those numbers also exist on the negative side of the number line, like negative 0.75. But the non-whole number, if it has a decimal or a fraction, they are rational, but they are not integers. So integers are just the positive and negative of the whole numbers and 0. So where do we use integers, or in general, where could we have negative numbers? We all think of lots of things we could count and use positive numbers, but temperature, at least here in the northern hemisphere, on a really cold day in January, the temperature outside may be -4 degrees Fahrenheit. On a warm summer day, it may be 87 degrees Fahrenheit. But those negative numbers are the really cold days. In Celsius, negative numbers would be all the numbers below freezing. Also a bank account. Positive numbers show up like you got paid, you made a deposit, but if you have written a check, or in this case, Itza's paid her rent, and it showed a transaction that with a negative number because money is being taken out of the bank account. Hopefully, for a balance, we would never see a negative number. We're in some trouble if that happens. That means we've tried to spend more than we have. So, absolute value is the distance between a number on the number line and 0. Just how far is it from 0? So I'm going to try to draw a little bit of a number line here. Let you take a look. Not sure why that's how I drew it, but that's okay. So here is 0. If this is 5 and this is -5, for example, both of those numbers, 1, 2, 3, 4, 5, both are 5 spaces. 1, 2, 3, 4, 5. Both are 5 spaces away from 0. It's like saying, how far is it apart? How far is it from 0? But I don't really care which direction. So absolute value. So we also see that written with some bars. So this would be read as the absolute value of 5, and it would be 5. But the absolute value of negative 5 is also 5. So a zero pair is just another phrase or word for opposites. So a pair of numbers that one has a negative sign, one has a positive sign, and their sum, that means when we add them together, we get 0. They would have the same absolute value. So negative 9 plus 9, 0. Positive 15, negative 15, 0. If I go down 9 steps and then come back up 9 steps, I'm back to where I started. Or if I deposit $15 and then immediately spend $15, my balance is 0. So when we compare integers, if we think about that number line, the numbers that are greater are further, the numbers are greater, the further to the right you go. And on a number line, numbers that are less are further to the left. So the further I get to the left, it's like I've taken a thermometer and laid it on its side, with the cold side to the left. And you see there, negative numbers to the left, positive integers to the right, and then 0 is right there in between, neither positive or negative. Again, very much like if we took a thermometer, laid it on its side with the cold temperatures on the left. So when you compare, you might think to yourself, is it better if I owe, so owing would be a negative thing, if I owe Andrea $5 or I owe her $13? So take a minute to think about that. So think about better, meaning better is further to the right. So negative 5 would be greater. I don't really want to owe Andrea at all, but it would be better if I only owe her $5 instead of $13. So next we're going to think about these temperatures, and we're going to compare them. Negative 10 and negative 3. So which one is warmer? 10, we also could call that 10 below 0 or 3 below 0. Yeah, 10 below 0 would be colder. So 10 below 0, negative 10 is less than negative 3. So the warmer one, the one that's greater, that's where the symbol is going to open up to. So you've seen me use some of these symbols as I've already started making some comparisons. And one way that you might remember is that an alligator would want to eat a lot. And so the symbol is going to open to the greater number and point at the smaller number. So when we read it, because in English we read left to right, then we call that first symbol, where it's open to the left, we would say greater. So for instance, 8 is greater than 4. That would look like this. And hopefully we can all agree that's true. 8 is greater than 4. Now if I write them in the other order, then my comparison symbol, my inequality symbol, would open to the 8 still, because 8 is still greater. But when I read it, since I read from left to right, 4 is less than 8. So oftentimes we just call the symbol the greater than symbol or the less than symbol, but when we read it in English, we say is greater than no, this number is greater than another number. This number is less than another number. Little detail, but later on in math when you have some application problems and you'll see something where there is not the is, and then it means subtraction instead when we see less than, for example. All right, I didn't really have to do this. I could have just went to the next slide. So now we're going to take a chance. So go ahead and think about your answers. Remember that it should open to the greater number, and greater we mean warmer, or the one you would prefer to have in your bank account, or further to the right on the number line. So take a moment, pause me if you need to think about, before I tell you, to think about what symbols should go into each one of those. In class, I'll give everyone some time to think about these, and then after we fill them in, I want you to practice saying it, how it would be read. All right, pause me if you haven't given it enough thought. Pardon me. So I'm going to place these so that they are open to the number that would be further to the right. So I know that 50 seems like a really big number, but it's like if I had to choose between negative 15 in my checking account or negative 50, I don't want either one, but I would rather have 15 in debt than 50 in debt. So that's why I chose that way. Or you might think, which one is warmer? Now, any positive number is always greater than a negative number. If I have some money to the good or some money in my account, that's always better than having debts. So negative 12, we could say, is less than 8. What about 0? Negative 22 or 0. Which of those temperatures would be warmer? 0 is cold, but negative 22 would be colder. So think about how you would read each of these. So for that first one, I would read it as negative 8 is greater than negative 10. Negative 15 is greater than negative 50. Negative 12 is less than 8. And negative 22 is less than 0. Each of these we could write in the other order, but we would have to switch the symbol, right? The comparison would change. So I could say negative 10 is less than negative 8. Negative 50 is less than negative 15. So here I'm using is less than. And then down here, 8 is greater than negative 12. And 0 is greater than negative 22. So very similar to if I said, I am taller than Dana, then Dana would say, I am shorter than Carolyn. So when we compare two things, if we want to switch the order, the word's going to change, just like the symbol had to change. did a little more than I wanted to there. Sorry about that. So thinking about less and greater, and that further to the left on the number line is the least. And the one that's furthest to the right on the number line would be the greatest. So let's think about which way these should go. So again, pause me. Maybe jot down which order you think they should go in. Give everyone a minute to think about that. Again, you can pause me. So since I want to go from least to greatest, I'm going to look for my smallest number, which least is going to be the biggest absolute value that has a negative sign. So like the deepest hole, so to speak. So negative 15, then negative 8, then negative 4. Notice how it's like I'm getting closer to 0, right? It's like I'm down in a deep hole and I'm crawling my way out. And then 0. And then now I'm in my positive numbers. So 2 and then 4. So from least to greatest, the least would be negative 15, the greatest would be positive 4 of those 6 numbers. So when they're in the negatives, the bigger the number part, the absolute value, if it has a negative sign, if it has the biggest number part, but with a negative, it's actually the least, or like the coldest. So think of least, coldest, or furthest to the left. So if Sylvia borrows $8 from Jayla, so borrows would be a debt. We would consider that negative. So she borrows 8 from Jayla. So that puts her here at negative 8. And then a week later, she repays her $5. So she's going to give her 1, 2, 3, 4, 5. So now she's still, so we get negative 3, which means she still owes Jayla $3. I'm getting a little heavy on my finger, apparently. Would it always be handy to use a number line when we're doing that addition and subtraction work? Think about my number line here. Can you think of any time you need to add or subtract numbers, but the numbers are bigger than 10? Probably lots of times, right? Most things that happen in my bank account are numbers bigger than 10, right? Our utility bills, all sorts of things. So a number line will not always be helpful. It can help us think about how the rule works or why the rules work, but we're going to want to have another way besides counting, because we'll spend too much time making a number line big enough. So if you will get out this page, you should have this notes page. And then as I go through some of the things on this next page, you're going to fill in the addition rules on this page. All right, so this is where you're going to write the rules that I'm going to go over. You're going to write them on this page of your notes. So when it has the same signs, we're going to add the numbers and keep the sign. When it has different signs, we're going to first ignore the signs. So if we ignore the signs, we're basically thinking about the absolute value, right? Just the number part. And then we're going to subtract the smaller one from the larger, but sometimes I call it bigger number wins. Keep the sign of the largest. So those are the two rules. So going back to your notes, and we can fill them in. So hopefully you filled in something similar to this. So same signs. We're going to add the numbers. And keep the sign. So an example, we'll have some more examples also, but -5 plus -3, same signs, make -8. And of course, things like we always have known, 2 plus 7 is 9. So if they're both positive numbers, of course, when we add them together, they're still positive. If they're both negative, like you lost 5 and then you lost 3, well, that's just a bigger loss, so it's still negative. When the signs are different, we're going to subtract. I'm going to use this word that might be new to you, but we're going to subtract the absolute value. So when I say that, I mean number only. Don't use the sign. And then give the answer. The sign of the greater absolute value. And sometimes people think of this as like good guys and bad guys. And if there's more good guys, we're going to end up with a positive. And if there's more bad guys, negative, we're going to end up with a negative. So something like this. -3 plus 5. So I'm just going to do 5 subtract 3 is 2. And the bigger number, the bigger absolute value, 5, so it's +2. When it's positive, we don't have to write a plus. In contrast, if we had -7 plus 3, so I'm going to do 7 take away 3 is 4, but the bigger number was negative, so it is -4. And I don't normally write this for this number so small as that. I just kind of think about it. So same signs add, opposite or different signs subtract, and then give the answer the sign of the bigger number. So bigger number wins in adding. Okay. All right, so we're going to go through and do some more examples, but those are just a few things you can have on your notes. Right, so here are some same sign examples. -4 plus -3. Same signs, add, keep the sign. 5 plus 2, both positive numbers, add, keep the sign. Both negative numbers, add, keep the sign. And here is an example when the signs are different. So just ignoring the signs, so we're just focused on the number portion. We're going to subtract 10 and 5. So I'm doing 10, take away 5 is 5. But bigger number was negative, so negative 5. That's how we get here. You could use your number line, begin at negative 10, move 5 to the right. We would still be in the negatives, right? We'd be at negative 5. And I would probably show you more on the number line, except that I know you should already have some experience with this. This hopefully is not a difficult day. But sometimes we make a lot of assumptions about what people remember, and it can be good just to go back over it some. And yes, you will be allowed to use a calculator, but many times I see people missing things because they didn't realize they punched the wrong button, and they probably would have been more accurate if they just understood the rules a little better. So this one again, different signs, so subtract, and the larger number here is positive, so the 4 is positive. So we have some problems next that in this case I'm not going to stop the video for 5 minutes, but I would just say to pause and write down your answers on paper, and then when you come back, I'll have them done, and you can check your work with mine. All right, did you try them on your own? Pause the video if you haven't. All right, you did try them on your own? Great. All right, so I'm going to kind of run through my thought process pretty quickly. Number 1, I see different signs, so I'm going to subtract, and the larger number is positive, so it's positive 1. Number 2, 0 plus anything is simply that number. 7 plus 1, they're both positive, so I'm going to add, and it's going to stay positive. Number 4, opposite signs, so I'll subtract, but the bigger number is negative, so my answer is negative. Number 5, same signs, add, and they're both positive, so my answer is also positive. Looks like the same rule for number 6, 5 plus 10, and both positive, so also positive. Anything plus 0 is just itself. So negative 6, negative 9 plus negative 1. So same signs, add, and keep the sign. 0 plus anything is just the other number, right? Negative 4. Number 10, negative 5 plus negative 5. So 2 negatives, so same signs. I lost $5, I lost another $5, I've lost $10, negative 10. Same signs, so you want to ask yourself, are they the same or different? They're the same signs. And I add them and keep the sign. Same signs, add them, keep the sign. So take a moment to check and see if we are in agreement. I'm giving my answers a quick scan to make sure I'm not leading anyone astray. Fantastic. So you might be surprised how often questions as easy as these in a step of a problem are missed because someone is using their calculator but accidentally presses the wrong button. So personally, I trust my brain a lot more than I trust, my finger. Not that the calculator is going to make a mistake, but if I accidentally push a wrong button, it certainly could. So trust your knowledge. All right. So let's get back to our next slide. So now subtraction. So this can get a little interesting because you might be thinking, wait, we've already been subtracting sometimes. So subtraction we can think of as adding the opposite. So I hope you feel really confident with the addition rules now, because we're going to change the subtraction problems into addition and then follow the rules for addition. All right, so there's a couple places where we might be able to take a little bit of a shortcut, but that's the general rule, is that subtraction is the same as adding the opposite. So you might have heard someone say before, keep, change, change. We're going to keep the sign of the first number, change the subtraction to addition, and change the sign of the second number, or in other words, make it its opposite. So we're going to add the opposite, follow the rules for addition. So what does it mean to add the opposite? It means we change the subtract to add and change the sign of the second number. All right, so if you don't really like the way that flows, you might just go ahead and get what I get from the next slide. This is what your note page looks like for you to write things on, besides whatever you might be writing on paper. So in this case, the first thing we have here is pretty obvious, right? We might all already know this. So if I was at 10, take away 4, so move to the left 4, then my answer would be 6. So 10 subtract 4, we all already know how to do 10 subtract 4. But I could also rewrite this as 10 plus negative 4. Now, if it is just two positive numbers, like 10 minus 4, I'm probably not going to do that. I'm just going to do 10 minus 4 is 6. But the rule works even on something that easy. If I change the subtract to add and change the sign of the second number, then I see, oh, they're different, so I subtract, and the bigger one is positive, so it's 6. Another way to think about subtraction is that it's asking you how far apart two numbers are. So if instead of counting back, if I think about 10 and 4, how far apart are 10 and 4? 1, 2, 3, 4, 5, 6. So 10 minus 4 is 6. That's another way to get the same answer. Got lots of choices here, don't we? So 5 subtract 7. So if I change that, right, change subtract to add, and then change the positive 7 to negative 7, then I see, oh, they have different signs. I'm going to subtract. But the bigger number was negative, so negative 2. We could also begin at 5 and move left because it says minus 7. 1, 2, 3, 4, 5, 6, 7. And there's our result, -2. So from here, left 7. There's my minus 7, or -7. So without completely rewriting this, another way to think of it is this is 5, and this is -7. Think of the minus sign being stuck to the 7, and then combine those. Oh, they're different. I'm going to subtract, and the bigger one is negative. And that kind of thought process is going to be very helpful because as we get into algebra, we're not usually going to rewrite. We're just going to think of the sign being attached to whatever follows. So we know now that if there's just one number, one sign before the number, you can just think of it like belonging to that number, like we just did, what I just talked to you about. So like a -5, a -2. So then I would say same signs. I would say or think to myself, add and keep the sign. So that would be -7. But when there are two negative signs next to each other without a number in between, that's going to become positive. So because of add the opposite. So if I change subtraction to addition and then the opposite of -3, +3. And they're the same, both positive. So that could also have happened like this. -5, subtract -2. Those two negatives together become positive, but this time those would be different. So I would subtract, and in this case the negative is bigger. So it doesn't mean that you would always add. It throws you back to the addition rules, which sometimes means we subtract. Okay, so -2, subtract 5. Yeah, they both have negatives, so -7. Good.
If I walk on a treadmill, it won't be bother anything, huh?
It really is -7. So -2, back 5 more, -7, all right. We could also think about the distance between them, -2, +5. How far are they apart? They are 7 spaces apart, but we start it to the left, so -7. That may be a little more than you want to think about, but just another way. Typically, I would not really even use the number line. I would just see a negative with my 2, a negative with my 5. Same signs, add them together, keep it negative. Oh my gosh. I don't mean to keep taking that back out of that. 2 subtract 8. Yeah, -6, right? That was -6, I promise. And then -5 subtract 7. They both have their own negative sign. So same signs, add them together, keep it negative. two negatives together, it's going to become a plus. So then this turns into 2 plus 7. So now they're both positive, so same signs add and keep the sign. So it's going to stay positive. Very similar. Those two negatives together are going to make a plus because we add the opposite. So subtraction sign changes to addition, opposite of -5, +5. So we'll add them together and keep it positive. All right, so now there's some subtraction problems coming up for you to try on your own. Pause me, give them a try. This time I'm just going to write down my answers and have you come back. Also, I see this is getting pretty long. I hope you know you can always fast forward if I'm moving too slow. Okay, give those a look. Awesome. So remember that the two negatives together, it's going to subtract a negative. It's going to turn into a big old plus. And then I'm just following those many times. I can change these to being plus -2. But normally in a situation like this, I'm just thinking -4 and -2. Same signs add, keep the sign. So up here, 7 and -9, different signs, subtract, bigger number has a negative sign, so -2. I think that is probably the easiest, is just thinking of these two as the numbers and just knowing if there's the two negatives together, it's going to change to a plus. All right, so if you have kids, or maybe you are a kid or a kid at heart, and you've been to an arcade, and maybe you earn some tickets and then you get to go spend them on prizes. So winning would be a positive thing. Spending your tickets would be negative. So here he has 105. He won 27. Then he spent 100. So I could think that as minus 100 or plus -100. But he had 132. He spent 100. So he now has 32 tickets. So on Monday, the price of gas decreased 10 cents. Oh, hello, let's go backwards here. I did not go backwards, I went forwards. So decreased 10 cents, then it increased 6 cents. So opposite signs subtract. Larger one is negative. So overall, the change in price was -4, or we could say decrease 4. Excuse me. Another application would be temperature. So if at 7 a.m. it was 10 degrees, and it rose by 7 degrees, and then it had fallen 20 degrees since then. So it was 10 up to 17, now down 20 degrees, so -3 degrees. So here we are, we're at 10, up 7, but then down 20. I'm so sorry, I have made this way longer than I intended to. I have to take a few slides out. So our rules for multiplication and division, again, you should put this on your paper, much easier than adding and subtracting because they're very much more clear-cut. When we're looking at just two numbers, if the signs are the same, the answer is positive, and if the signs are different, the answer is negative. Again, this is when we're looking at two numbers at a time, and the same rule applies for multiplying and dividing. So you can write that. So multiply or divide like normal, right? And then the answer is positive. Hello. Might need that O in that word. And if they're different, again, multiply or divide, depending on the problem. And the answer is negative. It does not matter who's bigger. Right? It doesn't matter who's bigger when we're talking about different signs for multiplying and dividing. All right, so those rules are so much easier. You already have some practice to do. Again, if you want to try it before I write it down, go ahead and pause me and then give them a try. Come back when you're ready to see the answers. All right, so notice if the signs were the same, the answer is positive. Right? Signs are the same, signs are the same, signs are the same, signs are the same. Positive answers. Signs are different, negative answers. Easy peasy. All right, so we're going to go back through and review this much more quickly. This is just kind of a wrap-up notes. And so we want to know those rules for adding, subtracting, multiplying, and dividing integers. So if numbers have the same sign, oh, hello, I don't want to use my highlighter. Same sign. Then add the absolute values and keep the sign. Remember, absolute value is just the number part. If numbers have different signs, then subtract the absolute values and keep the sign of the number with the larger absolute value. Bigger number wins. So for number 1, same signs or different signs? Yep, same. So I'm going to add 21 and 2 and keep the sign. Same or different? Same. 7 and 14, and they're both positive, so positive. Same or different? Different, right? Negative and a positive. So now I'm going to subtract. And the bigger one was positive, so positive 23. Different again. Notice when I subtract, I have to take the small number from the big number, even though the big number is one with the negative sign. We handle that by giving our answer a negative sign. All right, so that's adding. Now we'll move on to subtracting. So subtracting is the same as adding the first number to the opposite of the second number. This can be accomplished by keeping the sign of the first number. Maybe I should just say keep. So keep the sign of the first. Change the subtraction to addition and change the sign of the second number. Then follow the addition rules. So I'm going to keep, change, change. Now they're different. So I'm going to do 45, take away 32. But the bigger number was negative, so negative 13. Now, you don't want to rewrite. You could also think of this as negative 45 and 32. Again, they're different, so you're going to subtract. Keep, change, change. Remember those two negatives together? It's going to turn into a plus in the middle. Are they the same or different? They're different. 31 subtract 12 is 19. This case, the bigger number is positive, so it is positive 19. Keep, change, change, or simply think negative, negative. Now they both have a negative sign, which is the same as if I did keep, change, change, because I would have had this. So they both have a negative sign, so they have same signs. I'm going to add them together and keep it negative. Oh, we get a long one here. So here in the middle, I see 2 minus, so that's going to become plus. But then this guy is just negative 6 and negative 7. So I can go left to right, or I could put my negatives together first. I'll go left to right. So when I look at negative 7 and plus 14, they're different, so I'll subtract. And then 7 and negative 6, or 7 subtract 6, they're also different, so I'll subtract. All right, Mickey Mouse here is a little new to me. These rules are not new to me. They're the same rules I've told you before. But if using the little Mickey Mouse would help you remember the rules, go for it. Just notice that it's only for multiplying and dividing, not for adding and subtracting. So multiplying or dividing two numbers that have the same signs results in a positive answer. And multiplying or dividing two numbers that have different signs results in a negative answer. So if you copied down Mickey Mouse and then you covered up what you have, then what's left is what the answer is. So, for example, if I had -3 times +5, so a negative and a positive is going to equal -15. And if it was two positives, well, we already know two positives is a positive because that's the way it's always been, right? What if it was two negatives? Those will be covered up, so it's positive. That's how that works. Again, works for multiplying, works for dividing, does not work for adding and subtracting. But I think you know that. And then here are some multiplying and dividing problems. Work through quickly. Different signs. I know this is negative. Also notice how there are some different ways that we might see multiplying. We might see a dot, we might see the star, we might see the X, we might see parentheses. But when they have the same sign, I get positive answers like 10 and 12. When they have different signs, we get negative answers. And division we'll often see as a fraction. One negative sign means it's negative. Two negatives, it's positive. One negative, negative. The slash, another way to write a fraction, also means division. No negatives, of course, it's positive. All right, very well. All right, so that is way longer than I intended for some review about integers. But I will make a note with this that you can fast forward